After completion of these initial runs, sea engine tests will be scheduled. Nearby, Stand 1-5, construction of the dry flame bucket was completed early in June. Composed of high-strength cement, buckets of this type will be put into use at operational sites. At Stand 1-1, Missile 7B was in the tower and readied for first hot tests. The Corps of Engineers early in the quarter reinforced the blockhouse roof at this stand. With these changes, the blockhouse can withstand a blast equivalent to 100,000 pounds of TNT. We demated Missile 7B shortly after erection. This normal operation permits technicians to service the sustainer and to make final adjustments before firing. In an area removed from the test stands on Lumen Ridge, construction continued on the research test site. These tanks will be used to evaluate high-flow propellant loading techniques in the first phase of test. Next quarter, testing will be accelerated with activity at all 6 stands now supporting the Atlas program.
On the 7th of May, the Atlas transport team opened a new route for the ICBM. This time, from San Diego up the Pacific Coast Highway to Cook Air Force Base. This was the second assignment for Missile 5A, which had been subjected to a series of hot-firing evaluations earlier in the program. The missile is essentially complete, but will not be fired, since it was expended in the earlier tests. Accepting for the Air Force was Major General David Wade, commander of the 1st Missile Division. Construction at the Air Force Missile Base is progressing rapidly. The first Atlas launch site here will be Complex 65-1. Status of construction on this project will be described by Bill Stanley, Chief Plant Engineer for Convair Astronautics.
The Atlas site here has been under construction since June 1957. The Corps of Engineers has the task of construction with surveillance by Convair Astronautics. I'm standing on top of the blockhouse from which launchings will be controlled. There are 3 launch stands visible from here. They are arranged triangularly around the blockhouse. You can see the cable racks which lead from the control center to the stands. From the air, Launch Stand A appears at 11 o'clock, with Stand B at 7 o'clock, and Stand C at 3 o'clock. Launcher A, northwest of the blockhouse, is nearest completion. The flame deflector was installed in this launch stand. During the quarter, the contractors were well along with the installation of fuel and oxidizer tanks, process piping, A.D. Little rapid fueling system, and electric power. And we're also ready to begin installation of the service tower tracks. Launcher B is located southwest of the blockhouse. This will be the second launch stand to be activated. Progress is 1 month behind that of Stand A. The launch stand C is northeast of this position. Launch stands B and C will be completed in 1 month increments following completion of A. This structure, called Squadron Maintenance Area, will house the Convair Astronautics Operations Support Crew. The building was completed during this quarter. Occupancy began by mid-May. Missile 5A, which arrived here May 7th, is housed in the Squadron Maintenance Area. The highlights of the flight test program will be described by our key people in Florida. Convair's base manager at AFMTC, is Mr. B.G. McNabb. Here at Cape Canaveral, Convair activities during the second quarter centered around the successful completion of the Series A test. The first flight of the quarter was the launching of Missile 15A. This was the last missile with the 270,000-pound thrust booster package. The significance of this test was the importance of the data obtained.
15A exhibited good stability at takeoff and during initial stages of flight. This is one of the recordings taken during the flight test. First indication of a malfunction came with a signal from the bird, which showed a failure in one of the booster turbo pumps. This was one of 179 measurements recorded. The instrumentation effectiveness was 97%. From this flight record and from data taken during Thor and Jupiter flight tests, a fix was made on the problem and necessary modifications were accomplished.
The first of the advanced missiles received here was 3B, which arrived on April the 12th. This missile went through the normal inspection, calibration, and checkout at Hangar J, and was erected in the service tower at Complex 11 on April the 29th. Included in this tower are provisions for demating the thrust section from the tank and for installing the nose cone. On May 31st, the second and third missiles, 4B and 5B, arrived at AFMTC. 4B will flight test systems refined from previous flight test articles. 5B is significant in that it will be the first to test the full design capabilities of the guidance equipment. 2 weeks after arrival, Missile 4B was placed in position at Complex 13. The final flight test of the quarter on June the 3rd was the highly successful flight of Missile 16A, which concluded the A-Series test program.
At launch, 16A weighed 201,700 pounds. Thrust was 299,000 pounds. During this test, continuous useful data was obtained from 194 separate sources on the missile. Some special instrumentation was included to evaluate the turbo pump changes. At engine cutoff, missile weight was 48,800 pounds. Thrust was rated at 346,000 pounds. At this time, 16A had reached an altitude of 201,944 feet with a range of 41.7 nautical miles. Its velocity was 8,712 feet per second. Maximum altitude, or apogee, was 606,000 feet with a range of 234 nautical miles. Missile 16A continued through its trajectory for a flight time of 460 seconds. Its impact point, 480 nautical miles from the launch site.
At the end of the quarter, the first 2 B missiles were in place, ready for flight test. The re-entry nose cones are jettisonable and are to be installed on the missile 1 day before flight. Instrumentation includes a recoverable recorder, a 1-pound and a 4-pound SOFAR bomb, dye markers, and a CW beacon to aid in recovery. These Atlas flight tests are to be the first in which actual measurements are taken of the environment which exists when the nose cone re-enters the atmosphere at high velocity.
At the conclusion of the A-Series test program, the accumulated run time for static and flight missiles was equivalent to the engine run time of 48 A-series flight tests. The 8 flight tests conclusively demonstrated the capability of the basic configuration, along with launching equipment and the required ground support systems. As the A-series program was concluded, static testing of B-series missiles moved ahead in preparation for full-powered staging flights scheduled for the third quarter of 1958.